In the last lesson, we were introduced to the term mole, and remember that mole is just a counting number. So it basically just scales up our reactions to something that we can see. Okay, and we also talked about molar mass, where the mass that's reported on the periodic table coincides with the mass of 1 mole of that substance. Okay, and recall that a mole is just 6.022 times 10 to the 22nd. So we're going to continue on with our lesson. So here in Model 2, we have the composition of compounds. So over here, we have our different elements. Okay, so I have like the dark small circle. It has a mass of 1 AMU. So this would be like a single atom if we were comparing this to like our elements on the periodic table. Okay, we have our triangle. It has a mass of 16 AMU. So this is the mass of a single atom of a triangle. Okay, AMU just means atomic mass unit. Okay, and then we have the square that has a mass of 12 AMU. Okay, so for number 14, what is the molar mass of the element with our circle? Okay, so since our mass of a single atom would be this, that means that if we have the molar mass, we scale it up to 1 mole of that shape, we would have 1 gram per mole. Because remember that the unit for molar mass is grams per mole. So for number 15, what is the molar mass of element triangle? Since 1 has a mass of 16 AMU, if we scale that up to a single mole, we would have 16 grams per 1 mole of our substance, the triangle. For number 16, notice in Model 2, element circle and triangle have combined to create compound 1. What is the count of each element in the compound? So here is compound 1. Okay, so here it is combined together. So it's asking how many of the circles do we have and then how many of the triangles. So we have 2 circles and we have 1 triangle. Okay, so for question 17, what would be the overall molar mass of compound 1? So we'd have to combine the mass of all 3 elements that are combined together here. Okay, so we have 2 of our little circle, which just has a mass of 1 AMU. Okay, or I guess we're finding molar mass, so we should probably use grams per mole. Okay, plus the mass of our triangle. We only have 1 of those, so plus just 1 of my mass, 16 grams per mole. Okay, so if we add that together, we're going to get 18 grams per mole would be the molar mass of this compound 1. Okay, for number 18, what would be the overall molar mass of compound 2? So for compound 2, we have the square, which has a mass of 12, and then we have 4 of our circles that have a mass of 1, so we'd have 12 plus 13, 14, 15, 16. So we're going to have a mass of 16 grams per mole. Okay, that would be my molar mass. Elements are not commonly found as single atoms. They are usually bonded to other elements to form molecules or compounds. To determine the molar mass of a compound, you must first determine the formula mass. Okay, that's where we get the AMU. And then we can convert that into grams per mole. So see the steps below for calculating the formula mass of calcium bromide. So step 1, we're going to find the mass of each element using the periodic table. So if we go back for calcium and bromine, okay, here we have calcium. It has a mass of 40.078. Bromine, which is here, has a mass of 79.904. So you'll see that I wrote those down in my first step. For step 2, we're going to count the number of each type of atom in the chemical formula. So if my chemical formula is CaBr2, I have a single atom of calcium and I have 2 of bromine. Okay, then we're going to multiply the number of the atoms by the mass of each atom. So I have 1 mole or 1 atom of my calcium. Okay, so it's just going to stay the same mass that we had before. And then I have 2 moles of my 79.904. Okay, so when I multiply that together, I get that. And then our last step is adding the masses together, okay? So like what we did in step 17 and kind of like what we did in 18, even though we didn't write it out, we just kind of went through each of these 4 steps, okay? So that gives us our formula mass, which is given in AMU. So if our formula mass is this given number, we can just change the AMU and scale it up to grams per mole. Okay, so this would be the molar mass of our calcium bromide. Okay, so for number 19, we're going to fill in the following chart. So we have the name of most of these. We don't have the name here. And then we have the chemical formulas for most except for our aluminum sulfate. And so we're going to find the formula mass for each. Okay, so for ammonia, we have NH3. So we have a single mole of nitrogen. So we're just going to have 14.007. Okay, plus we have 3 hydrogens. So 3 times the mass of hydrogen, so 1.008. Okay, and we're going to get 17.031, and then the unit is grams per mole. Okay, because this is formula mass. Okay, for our next one, ozone, we have O3. So we're just going to take 3 times the mass of oxygen. So 3 times 15.999. And I'm just getting that number off the periodic table. So I'm going to have 47.997 grams per mole for my formula mass. For water, I have 2 hydrogens and 1 oxygen. So I'm going to do 2 times my mass of hydrogen, 1.008, plus 1 times my mass of oxygen, so just the mass of oxygen, 15.999, is equal to 18.015 grams per mole. Okay. For our next one, aluminum sulfate, they did not give us the chemical formula, so we have to determine the chemical formula first before we can determine the formula mass. Okay, so aluminum, if we look at the periodic table, okay, remember that in terms of our charges or the ions that we form, remember this is a +1, this is +2, then +3, and then we're 4. Then we're going to start to go down. So -3, -2, -1. Okay, so again, +1, +2, +3. Then we have 4, which is like nothing. And then we go down, -3, -2, -1. So aluminum has a charge of +3. So aluminum, we have a 3+ charge, okay? And sulfate, because it ends in -ate and not -ide, that means that it's one of the polyatomic ions that's on your polyatomic ion list. So sulfate is SO4, and it has a charge of -2. Okay, so from here we're going to crisscross. So the 2 is going to drop down to the aluminum. Okay, the 3 is going to drop down to the SO4, and because we're dropping something other than 1 down, we're going to put it in parentheses. So our chemical formula is going to be Al2SO4 3. Okay, so for the formula mass for this, we have 3 different elements that we're going to be combining the masses of. So we're going to start with aluminum. So we have 2 aluminum, so 2 times the mass of aluminum, which is 26.982, plus, okay, here, because we have parentheses, remember we need to distribute this 3 and multiply by each of the subscripts inside of the parentheses. So for sulfur, I'm going to have 3 sulfur. So 3 times the mass of sulfur, which is 32.06. Okay, and then for oxygen, I'm going to have the 3 times the 4, so 12. So 12 oxygen, so 12 times 15.999. Okay, when I add all of these together, I'm going to get 342.132 grams per mole. All right, for this last one, they did give us the chemical formula. It's carbon and oxygen, and if we actually look at the periodic table, both carbon and oxygen are non-metals, okay? So this is a covalent bond. So with covalent bonds, remember we use those prefixes in order to name the elements. The compound, we only have one of the carbon. Remember, if we only have one, we just list the name of the element. We don't have to put the prefix mono for that. So we're gonna have carbon. Okay, and then the second term always has to have a prefix. So here I have two oxygens, so I'm gonna have di, and then I'm going to end my ending in "ide," so dioxide. So this is carbon dioxide. So I have one carbon, so I'm going to take the mass of one carbon, which is 12.011, plus, and then for oxygen, I have two oxygens, so 2 times the mass of a single oxygen, which is 15.999, is equal to 44.009 grams per mole. Okay, for question 20, it says, what would be the mass of 10 moles of water? Okay, so here we solved for the formula mass of water, and the formula mass is 18.015 grams per 1 mole. So if this is the mass of 1 mole, I would just have to take my formula mass times 10 in order to solve for what the mass would be. So I'm going to take my 18.015 times 10. Okay, to get 180.15 grams. Notice they're asking for just mass. They're not asking for formula mass. We'd already calculated formula mass. So when it's just asking for mass, it's going to be in grams. Okay, for question 21, it says a 300-gram sample of ammonia would be how many moles? So we did find the formula mass for ammonia. It is 17.031 grams per 1 mole. Okay, so if I have this many grams, and I know this is equal to 1 mole of ammonia, I can divide my 300 grams divided by my 17.031 grams per mole. Okay, so that my grams actually cancel, so I'm just left with moles. So my 300 divided by 17.031, I'm going to get 17.6 moles of ammonia.